Okay, everybody, so welcome to P2 Chapter 2, Circles. Very exciting, and again, another fabulous PowerPoint made from Dr. Frost. So, before we get started, we need to be happy with finding midpoints and perpendicular bisectors. So, we know that if A and B are perpendicular, okay, what do we know? Absolutely. If we multiply the gradients of this line and this line, we will get -1. So, to find the perpendicular bisector, first of all, what we're going to do is we can find the gradient of A and B, which we know we can do by doing y2 minus y1 over x2 minus x1. So we're going to have 7 minus 5 over 6 minus 2. 7 minus 5, is 2. 6 minus 2 is 4. 2 over 4 is a half. So if this is the gradient of the line A and B, is a half. The gradient of the perpendicular bisector, and I'm just going to put gradient of perpendicular, is going to equal -2. We should all be very confident with that. Now, if we were to find the equation of the perpendicular bisector, we need 1 point on this line. Now, in our case, it's going to be M, which is the midpoint. Now, to find the midpoint, you can add the two values together and divide them by 2. Or you can find the mean. For us, though, it's quite easy to see that the midpoint between 2 and 6, we have 4, and then between 5 and 7, we have 6. So now, using our equation of a straight line, y equals mx plus c, we know we're going to have 6 equals minus 2 lots of 4 plus c. 6 equals minus 8 plus c. C is going to equal 14. So therefore, the equation of the perpendicular bisector is y equals minus 2x plus 14. And again, we looked at this in pure 1, so we should be very confident with that. So what we're going to do is, if you could quickly test your understanding, you've got 2 questions to do. Off you go. So find the perpendicular bisector of the line A and B, where A and B have the coordinates of. So the first one is quite easy. We're just using numbers. So we know the gradient of AB is 17 minus 7, which is 10, over 10 minus 4, which is 6. So I get 5 over 3. So that means the gradient of the perpendicular bisector is -3 over 5. So now I need to find the midpoint of A and B. Between 17 and 7 is 12. And between 4 and 10 is 7. Now I can use these. So 12 equals m minus 3 over 5x plus c. So I'm going to have 12 equals -21 over 5 plus c. 12 over 5 is 60, so we're going to end up with 81. C equals 81 over 5. So then my equation of the line is y equals m minus 3 over 5x plus 81 over 5. So for part B, let's see. So we know the gradient of the line AB is y2 minus y1 over x2 minus x1. The perpendicular gradient, I'm going to flip it and multiply everything by -1. So I actually get x1 minus x2 over y1 minus y2. Yep. Yeah, so this is still y2 minus y1, because I'm only multiplying it to the numerator. Now what I'm going to do is to find the midpoint of, so the midpoint coordinates are x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So now what's going to happen is if I was to substitute this into my y equals mx plus c, I'm going to get a long, horrible equation. But do you remember the equation y minus y1 equals mx minus x1? You can use that. So it's so you can substitute it into that. It's going to be a bit messy, but it's just to see if you could do it abstractly. Okay then. And then part C, did we have time to get to that? Yeah, this is going to look a bit messy. Okay, let's move on to B. So a line segment AB is the diameter of a circle with centre 5 minus 4. If A has coordinates 1 minus 2, what are the coordinates of B? Okay, so if this is a diameter, you know that this diameter in the middle, and if A and B lie on the circle, then it stands to reason that M is the midpoint of AB, because we know we're going to have a radius and a radius, okay? Now, it's only because it tells us that in the question. That is the diameter of the circle. They lie on the diameter, and it says that this is the centre. So what I always think is, how have I gone from 1 to 5? What have I done? Now, I just like to draw this. I've gone across 4. And then I've gone from minus 2 to minus 4. So I've gone down 2. So it stands to reason then, to get from M to B, I need to go across 4. 5 plus 4 is 9. And then I need to go down 2. Minus 4 minus 2 is minus 6. So as we always say, when in doubt, draw it out. Completely brand new equation of a circle. Now, if we think about 0, the centre of the circle being 0, 0 for now, okay? So here's my centre. And we can say that this coordinate xy is on the circle. Does anybody know what equation x and y must satisfy with the radius? Okay, and here we have a right angle triangle. What comes to mind? So, right angle triangle, we should be thinking Pythagoras. So, it stands to reason that x squared plus y squared needs to equal our radius squared. So this is all well and good if our centre is 0, 0, okay? But what happens if we move the circle, and instead of the centre being 0, 0, our centre is now AB. So now our circle is actually not in the centre. What do we think is going to happen? Take a really good think about this. Well done, absolutely correct. So this stands to reason that x minus a squared plus y minus b squared must equal r squared. And this is the equation of a circle. So what we're going to do is we're going to write a few equations of the circle. So here we go. If our centre is 0, 0 and our radius is 5, our equation is going to be, now remember it's x minus a squared plus y minus b squared equals r squared. So in this case, our a and b are our coordinates that we've been given. And it's 0, 0. So we're just going to be left with x squared plus y squared equals 5 squared, which is 25. For the second one, if we have points 1, 2 and radius 6, our equation of the circle is x minus a, which is 1 squared, plus y minus b, which is 2 squared, equals 6 squared, which we know is 36. So using this, can you work backwards from the equation of the circle to find the centre and the radius, please? So going backwards, I know that this should be minus a. Okay, I currently have 3, so minus a, this is going to be minus 3. And then here I've got minus 5. So minus b equals minus 5. So that means b equals 5. And then my radius is the square. Remember, this number on the end is r squared. So square root of 1 is in fact 1. Okay, then the next one, my coordinates are going to be minus 5, 2, and my radius, 7. Fantastic. For the next one, my coordinates are going to be minus 6, 0, and my radius, 4. For the next one, my coordinates are going to be 1, minus 1, and my radius, square root of 3. For the next one, my coordinates is going to be minus 2, 3, and my radius, root 8, which we could also write as 2 root 2. So if we're given 2 points which are a diameter on a circle, and it asks us to determine the equation of the circle, what do we need? Well, we know for the equation of the circle we need the centre point and we need a radius. How do we find the centre? Well, we know if these 2 points are on the circle and it said that the line segment AB is the diameter, we know it passes through the centre if it's a diameter. So to find the centre, all I need to do is find the midpoint because it tells us this is a diameter, okay, and all diameters pass through the centre. So to find the midpoint, if I wanted to, I could do minus 7 plus 5, which is minus 2, divide that by 2, I'm going to get negative 1. And then I've got 4 plus 8 is 12, divide that by 2, 6. So there's my centre. So I know my centre is minus 1, 6. How am I going to find my radius? Now my radius, I need to find the distance. Now, lucky for me, I know that if I've got 2 points, I can draw a triangle. And from minus 1 to 5, my distance is 6. And from 6 to 8, my distance is 2. So I can use Pythagoras. 6 squared plus 2 squared equals our radius squared. And 6 squared is 64 plus, 36. I had 8 squared in my head for some reason. 36 plus 4 is 40. So 40 equals r squared. So the square root of 40 equals r. So now I have my 2 pieces of information. Now I know the equation of the circle is x minus a. Now our a is -1, so minus 1, this is going to become +1 squared, plus y minus 6 squared equals root 40 squared, which we know is 40. Okay, so test your understanding. This is a core 2 January 2005 question. 6 marks here. Off you go. So 6 marks, this is not going to take us 6 minutes. Are we ready? So they have coordinates 5, -1, 13, 11. To find the midpoint, what we're going to do, 5 plus 13 is 18, divided by 2 is 9. -1 plus 11 is 10, divided by 2, I get 5. So here's our midpoint. Now our midpoint is also the centre of the circle. It also wants us to find the equation of C. So if you think we've got 9, 5 as the midpoint, and if I was to choose 13, 11, I need to draw my right angle triangle. Between 9 and 13 is 4, 5 and 11 is 6. So I'm going to have 4 squared plus 6 squared equals 16 plus 36, which is 52. So my r squared equals 52. Now you don't even have to square root r really here if you don't want to. You can say r is root 52. But we know the equation of a circle is x minus a squared plus y minus b squared equals r squared. So we're going to have x minus 9 squared plus y minus 5 squared equals 52. And that took a grand total of 1 minute 30 seconds. So, as you know, sometimes when they give us these questions, they don't give us to it in this form. They have an expanded version. Now, for us to be able to get it into this form, to find the centre and the radius, what we need to do is we need to complete the square. So, if I have x squared plus y squared minus 6x plus 2y minus 6 equals 0. The first thing I'm going to do is collate all my x's together. So I'm going to have x squared minus 6x plus y squared plus 2y minus 6 equals 0. Now what I'm going to focus on is completing the square on my x squared minus 6x. So I know this can also be rewritten as x minus 3 squared minus 3 squared. And the same for my y. I'm going to rewrite this. Now it's really important. In this example, we've got plus y squared. Okay, so that's okay. But if we get to an example with a negative, I will show you what to do. We're going to have plus y plus 1 squared minus 1 squared. And then obviously at the end, we're going to have minus 6 equals 0. So now I'm going to have x minus 3 squared plus y plus 1 squared. And then I'm going to have minus 9 minus 1 minus 6 equals 0. So I'm going to have x minus 3 squared plus y plus 1 squared equals 16. So now I can say that my centre is 3 minus 1 and my radius is 4 because we know it's the square root of 16. So this is how we find the centre and radius of an equation in this form. So I'm going to do one more example. And you can see here, this is a 5-mark question, okay, from the 2012 paper. So step 1, we're going to rewrite the equation x squared minus 20x plus y squared minus 16y plus 139 equals 0. I'm going to complete the square on my x's. So we're going to get x minus 10 squared minus 10 squared. I'm now going to complete the square on my y plus y minus 8 squared minus 8 squared plus 139 equals 0. So this is now going to give me x minus 10 squared plus y minus 8 squared minus 100 minus 64 plus 139 equals 0. So now I'm going to have x minus 10 squared plus y minus 8 squared. 64 to 39 is 25, so this equals 25. So that means my centre is 10, 8, and my radius equals 5. So what I would like you to do is I'd like you to practice this, please. If you are, just a bit like you're okay, go for 9. If you are amazing, can you go for 11? And let's just have a few minutes doing that. So, we know that we could have multiple lines. We could have, on a circle, it could touch once, and that would mean it's tangent to the circle. We could have a line that goes across. Okay, it has 2 intersections. This is known as a secant. Then we have a line that could be here. It has no intersections. So if we have to show that something intersects or it doesn't intersect, what is the first thing we should be doing? Yeah, we need to make them equal to each other, okay? Now, in this case, though, because we have y equals x plus 3, and we have an x squared plus y squared equals 1, normally we'd put them equal to each other, but that's only because they both, normally to show 2 lines intersect or a line in a quadratic, we'd always have y equals and y equals. That's why we put them equal to each other, because essentially what we're doing is substituting in. So here we have y equals x plus 3. So what we're going to do is we can't just put that equals this side because that's not what y equals. We're going to substitute that in here. So we're going to have x squared plus x plus 3 squared equals 1. I'm now going to expand, simplify. So I'm going to x squared plus, we're going to have x squared plus 6x plus 9 equals 1. That means that we're going to have 2x squared plus 6x plus 8 equals 0. Now, to show that it doesn't intersect, what we then need to use is the discriminant. We need to prove that b squared minus 4ac is less than 0, because this would mean it doesn't intersect. If this is true, so we know our a equals 2, b equals 6, and c equals 8. So we're going to have 8 squared minus 4 lots of 2 lots of 6. We need to prove this is less than 0. Now 8 squared is 64. 64 minus 4 times 12. What's 4 times 12? Oh, yes, I've completely gone wrong. Great mistakes. That is not less than 0. Okay, let's try this again. Our B is 6. Our A is 2. And our C is 8. So we're going to have 36 minus 4 times 16, which is 64. Is that less than 0? We're going to get 28 is less than 0. Is that right? Yeah. Therefore, this is negative 28. Therefore, no solutions. Okay, any questions? Now what I want you to do is test your understanding. So it says here, find the points of intersection where the line y equals x plus 6 meets this circle. And then it says, using an algebraic method, determine the value of k such that the line y equals x plus k touches the circle with the equation. So for the first one, we know it says find the points of intersection, and it clearly says points, so that means that they do intersect. So for the first one, we're just going to substitute them into each other, make them one equation, and then we'll be able to solve it. For the second question, it says determine k such that it touches the circle with the equation. If it touches, that then means that our discriminant is b squared minus 4ac equals 0, and we will be able to find the range of values for k. So give it a go. So for the first one, we should substitute in the value of x plus 6 into y. So we're going to get x plus 6 minus 3 squared equals 29. So we're going to have x squared plus x plus 3 squared equals 29. So we're going to have x squared plus 6x plus 9 equals 29. So we're going to have 2x squared plus 6x minus 20 equals 0. Then what we're going to have is, if I wanted to, I could divide all that by 2. To have x squared plus 3x minus 10 equals 0. So we're going to have x plus 5 and x minus 2 equals 0. So x equals negative 5 and x equals positive 2. I'm now going to substitute that back into my y equals to find my y coordinates for each one. So I'm going to have y minus 5 plus 6. So y equals 1. And I'm going to have y equals 2 plus 6. So y equals 8. So it's really important. It says find the points of intersection. You will need to write these as coordinates. Minus 5, 1 and 2, 8. Using an algebraic method, determine the values of k such that the line y equals x plus k touches the circle. So if it touches, it means it has one solution. So we've got to be able to find our values of k, we know that b squared minus 4ac equals 0. Before we start that, we need to have one equation. So I'm going to substitute in y equals x plus k into the equation. So we're going to have, oh sorry everyone, accidentally put y equals x plus k. So I'm going to have x squared plus, x squared plus x squared plus 2kx plus k squared minus 1 equals 0. So I'm going to have 2x squared plus 2kx plus k squared minus 1 equals 0. So our a equals 2, our b equals 2k, and our c equals k squared minus 1. I'm now going to substitute that in to my equation. So b squared is 2k squared minus 4 lots of a, which is 2 lots of c, which is k squared minus 1. This equals 0. Then we're going to have 4k squared minus 8k squared plus 8 equals 0. I now need to solve this, and I'm going to use my calculator. So, yeah, minus 4k squared blah, 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 plus 8 equals 0. So then I'm going to get k squared equals 2. So that means that k equals plus or minus root 2. So there's two values, because remember, if you had a circle here and it touches the point, we could have one line here, but this same line, we have a positive, we could also have here, okay? And it could just touch it once, there and there. So we could have two different, and you can clearly see here that actually the y-intercepts, we're going to have positive root 2 and negative root 2 for our y-intercepts. Okay, question 9. The circle of the equation meets the straight line with this equation at points A and B. Okay, so we know that they intersect twice. So what I'm first going to do is substitute in and solve it. So I'm going to have y equals x minus 5 and x minus 4 squared plus y plus 7 squared equals 50. So I'm going to have x squared minus 8x plus 16 plus x plus 2 squared, because if I substitute in x minus 5 into here, I get x minus 5 plus 7, which is plus 2, equals 50. So x squared minus 8x plus 16 plus x squared plus 4x plus 4 minus 50 equals 0. So 2x squared minus 4x minus 30 equals 0. X squared minus 2x minus 15 equals 0. So I'm going to have x minus 5, x plus 3, x equals 5, x equals negative 3. If I substitute that back into this one, I'm going to get y equals 0 and y equals negative 8. So the 2 points I have are 5, 0 and minus 3, minus 8. Did everyone get that? Perfect. Okay, find the equation of the perpendicular bisector of the line segment A and B. So this is what we did yesterday, okay? So, first of all, we've got to find the gradient of these two lines. So now we're on part B. So y2, yeah? Okay. So, are you happy with how I got 5? And then all I did was I substituted x equals 5 into this. 5 minus 5 is 0. Yeah? No worries. Okay, so now I know I'm going to do y2 minus 8 minus y1 over x2 minus x1. So I'm going to get minus 8 over minus 8, which equals negative 1. So this is the gradient of the line. So the gradient of the perpendicular bisector is going to be 1. Oh, absolutely. You're so right. Sorry, everyone. Getting ahead of myself. So this should be positive 1. This should be negative 1. So you can see I always like to play these tricks on you to make sure you're listening. Okay, then. So now I need to find the midpoint. Now, what's in the middle of 5 and minus 3? If I add them together, I get 2 divided by 2 is 1. And then in the middle of 0 and minus 8, add them together, minus 8 divided by 2, minus 4. So now I have my equation, y equals mx plus c. So I'm going to get minus 4 equals minus 1 lot of 1 plus c. So I can get minus 3 equals c. So then I get y equals minus x minus 3. So this is the equation of the perpendicular bisector AB. It says show that the perpendicular bisector of AB passes through the centre of the circle. So we know the centre is 4 minus 7. How did I get that, you ask? Because in the equation up here. So 4 minus 7, I've just got to substitute this in and show that it equals each other. So minus 7 equals x, minus x, which is 4 minus 3. Minus 7 equals minus 7, therefore passes through. Passes through. Okay, so that's all easy now. So we know it passes through the centre. It then says find the area of the triangle OAB. Okay, so when in doubt, what do we do? Everyone? Absolutely. We draw it out. So what we are going to do is when we draw this out, we need to think about exactly what's going on. So even though we're drawing it out, we're just drawing it out to get an understanding. We're not drawing it out to prove anything, okay? So I know I've got a centre of a circle 4 minus 7. So I'm just going to draw my straight line. 4 minus 7 is roughly here. I know that a line goes through it at 5, 0. Okay. And at minus 3, minus 8. Minus 3 is about here roughly. Okay. Now, that doesn't make any sense because what did we also figure out? Wait there, let's start this again. I need to draw this. I think I need to draw this. I need to really go in here. Right. So, what do we know? The centre is 4 minus 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, so that's actually going to be here. Here's my centre. Now, we know that it meets with a straight line, y equals x minus 5. So 1, 2, 3, 4, 5. So this straight line crosses at... Where would this line cross the y equals x minus 5? It's about here, isn't it? Okay, so we know this line crosses the circle, so this would be the edge of the circle. And then the next line, 1, 2, 3, minus 3, what was it? Minus 8. 5, 6, 7, 8. Will be here, and it's still on that line. So if I was to draw this circle, okay, let's see how this works. Yeah, that'll do. Okay, it's going to look something like this, okay? The only problem we have is, it then says show the perpendicular bisector. So we now know this perpendicular bisector crosses through the centre. So here, if I did the perpendicular bisector of this line, you can see it does cross through the centre. Maybe I need to make the circle a little bit smaller actually. Okay, I can't. But anyway, does everyone understand what's kind of going on here? The question then says, find the triangle, area of the triangle OAB. Now I know that this is, A is which one? Doesn't matter. Let's say this is A here. Minus 3 minus 8. And this is B here. 5, 0. Okay? And it wants AOB. Does anybody know what O means? Yeah, O's the origin. It would tell us if it wanted us to use the circle. So we've got to use this origin here. Okay? So, we want this triangle. That's what we want. How are we going to find that? Has anyone got an answer for this? Because it's only worth 2 marks. O to A, Y coordinates. So you're saying 8 times 5 divided by 2. Absolutely correct, Guido. Now, how did you do that? Like, what makes you come to that assumption? Yeah, but that's only base times perpendicular height. So which height are you using? Oh, you're doing origin to A here. Times origin to B. Yeah. So we're going to get 5 times 8 divided by 2. So the area is 20 units squared. Okay, now, for this question, we probably didn't need to draw it all out. I didn't realise what was going on. But there are other questions where actually we would just need to find the area of this sector. So you would need to draw it out, okay? So, tangents, chords, and perpendicular bisectors. So, there are 2 circle theorems that you need to know which are relevant to this chapter. So, we know that a tangent is perpendicular to the radius at a point of intersection. You need to know this. And also, the perpendicular bisector of any chord, okay, passes through the centre of the circle. So, this is bringing in all the skills we've learnt so far. So here we go. We have 2 examples, okay, and in the UK GCSE, they actually have questions like this, very similar, apart from the centre of the circle is always 0, 0. It's always the origin. So let's go through these examples then. The circle C has equation x minus 3 squared plus y minus 7 squared equals 100, okay? So it says verify the point P 11,1 lies on C. To verify a point lies on the circle, all we've got to do is substitute the values in and make sure it equals what it should. So our x is 11 minus 3 squared plus our y, which is 1, minus 7 squared should equal 100. Now 11 minus 3 is in fact 8. 8 squared is 64. 1 minus 7 is minus 6. Minus 6 squared is 36. This equals 100. 100 does equal 100. Therefore, P 11,1 lies on C. Okay, nice and simple. Then part B says find an equation of the tangent to C at the point P, giving your answers in the form ax plus by plus c. So what that means is find the equation of the tangent to C at the point P. Now again, if we go back to that circle theorem, we have our circle, we have our radius. Here is our tangent. So if we find the gradient of the center of the circle to the point P, we are then able to find the perpendicular gradient. So the gradient, we know the center of the circle is 3, 7. We know the point P is 11, 1. So we're going to have 1 minus 7 over 11 minus 3, which equals minus 6 over 8, which equals negative 3 over 4. So this is the gradient of the radius line. To find the gradient of the tangent, we know they're perpendicular, so we can flip it, times it by minus 1. So the gradient of the tangent is then going to be 4 over 3. We now have a point, P, so now we know y equals mx plus c. So our y is 1 equals gradient 4 over 3 lots of 11 plus c. So we're going to have 1 equals 44 over 3 plus c. 1 minus 44 over 3 is minus 41 over 3 plus c. Equals c. So that means, therefore, y equals 4 over 3x minus 41 over 3. But in the question it says clearly give your form in a specified form. Going to multiply everything by 3. 3y equals 4x minus 41. Move everything to the left-hand side. 3y, it wants the x first. Minus 4x plus 3y plus 41 equals 0. So there we have it, nice and simple. Then, wait there. Example 2. Circle C has equation x minus 4 squared plus y plus 4 squared equals 10. The line L is tangent to the circle and has gradient minus 3. Find two possible equations for L, given your answers in the form y equals mx plus c. So the reason why we have two possible equations for L is, as I've said, if the gradient's negative 3, we know that the line is going to be in this direction. And it could be here, or it could be here. You can see these two lines are parallel. So that's why we're going to have two equations, okay? So this is what's happening here. This is why we could have two. So what we need to do is, we know that if we start off just with this line here, for example, okay, we know, what do we know? We know our centre is 4 minus 4, okay, and our radius squared is 10. So what we need to find is the point, okay? We know the gradient, m equals minus 3. So we know the gradient between this point and another point is going to equal positive a third. Now, there is more than one way to do this. Y2, x2. So, what I'm going to personally do is I'm going to just try this way. So y2 minus 4 over x2 minus 4 equals y2 plus 4 over x2 minus 4. Now, what number, this needs to equal a third, okay? So what am I going to have first? I'm going to have y2 plus 4 equals a third. So I know that my y must equal minus 3. And then x2 minus 4 equals 3, so my x is equal 7. So then I've got 1 point minus, 7 minus 3 is 1 point on this line. Now, how is this going to help us find the other point? How are we going to find the other point? How are we going to find the second point? Let's say this point is 7 minus 3. Okay, it only gives us 1 point, but as we know, we could get 2 points. Yeah, we could see the distance. Now, our radius is 10. So, not our radius, sorry, our radius squared is 10. So that means that this is root 10. Now, if I was to start at 4 minus 4, and I know I need to move root 10, I need something squared plus something squared equals 10 squared, because this is essentially what's going on, isn't it? Now, in this case, I know to go from minus 4, how am I going to, remember because the centre is 4, minus 4. So I've gone across 3 and up 1. So I know to go backwards, I need to go across 3 and down 1. So that would then mean, if we look at the point 4 minus 3, if I take away 3, what do I get? 1. And then minus 4 minus 1 minus 5. So here is our other point. Now, this is one way to find it out. And if we just carry on with this for a second, we've got our points, we know our gradient. So now I'm going to have two equations because I know my gradient of my tangent is a third. I can substitute this in. So y equals a third lots, sorry, not y. Minus 3 equals a third lots of 7 plus c. So I'm going to get minus 9 over 7. No, that's not right at all. Sorry, I've just multiplied. So then I'm going to have minus 3 minus 7 over 3 is going to be... Have I done this right? No, I haven't, everyone. I'm getting my gradients confused. It's already told us the gradient of the tangent, which is minus 3. This is the one I'm using. The reason I used a third earlier to find the gradient of the radius. So then I'm going to have minus 3 equals minus 3 lots of 7 plus c. Minus 3 times 7 is minus 21. Minus 21, where if we move it to the other side, we're going to have 21 minus 3, which is 18. So I'm going to have c is 18, so y equals minus 3x plus 18. So this is my first equation. Second equation, again, sorry everyone with the confusion. Our gradient is minus 3 because it tells us that in the question. I'm going to get minus 5 equals minus 3 lots of 1 plus c. So that must mean my c is equal to minus 2. So I'm going to get y equals minus 3x minus 2. So there I found the two equations. Now, there is another way to do this, okay? The other way to do this is, and some of you might prefer this method, is we know we have our circle. We know the gradient of the diameter is negative 1 over 3. Because it's perpendicular to the gradient of the tangent, not negative, sorry, positive 1 over 3. Because it's perpendicular to the gradient of the tangent, and the gradient of the tangent we know is minus 3. We also have a point, 4 minus 4. So I can find the equation of this straight line. So y equals mx plus c. I'm going to get minus 4 equals a third lots of 4 plus c, minus 4 over 3 plus equals c. Minus 4, so I'm going to get minus 16 over 3 equals c. So therefore, the equation is y equals a third x minus 16 over 3. I now have the equation of this straight line here, the diameter. I can substitute that in to the equation of the circle to then find the 2 points at which it intersects. So if I substitute this in, I'm going to have x minus 4 squared plus y, which we know is a third x minus 16 over 3 plus 4 all squared equals 10. I can now solve this. So I'm going to have x squared minus 8x plus 16, and then a third x. I'm going to have a third x. 4, so minus 16 over 3 plus 12 over 3 is minus 4 over 3 squared. So I'm going to get a third x times a third x, which we know is 1 over 9x squared. We're going to have minus 4 over 3 times minus 4 over 3, which we know is 16 over 9. We're also going to have our minus 10 here. And then we're going to have minus 4 over 3 times a third is negative 4 over 9. 2 lots of those is negative 8 over 9x. I'm now going to multiply everything by 9 to get rid of these fractions. So I'm going to have 9x squared minus 8 times 9 is 72x. 16 times 9, 144. Is it? 16 times 9. Plus x squared minus 8x plus 16 minus 90 equals 0. I'm then going to have 10x squared minus 72x minus 8x is minus 80x. 144 minus 90 is 54. 54 plus 16 is 70 equals 0. I'm going to divide everything by 10. X squared minus 8x plus 7 equals 0. So I'm going to have x minus 7, x minus 1 equals 0. So x equals 7 and x equals 1. I'm then going to substitute that back into what my y is here. And then, so substituting that back in, let's just go up here now. God, it's very messy. Y equals a third lots of 7 minus 16 over 3, which is 7 over 3 minus 16 over 3, which equals minus 9 over 3, which equals minus 3. And then when x equals 1, we're going to have a third minus 16 over 3, which is minus 15 over 3, which equals minus 5. So you can see we've got the exact same coordinates as we did earlier. Now, this is the method they show you in the textbook. Personally, I prefer the method I've done here because it makes complete logical sense and will work as long as you understand what's going on. Okay? But this method will obviously get you to the correct solution as well. Okay, so one more example before you get to test your understanding. So in this question here, we've got to determine the centre of a circle. Now, what we learned earlier is that the perpendicular bisector of a chord will pass through the centre of the circle. Okay, so it says a P and Q line a circle with centre C shown in the diagram. The point P has coordinates minus 8, minus 2, and Q is 2, minus 6. M is the midpoint of the line segment, and the line passes through the points M and C. Now, I know it's told you that, but the midpoint of a chord will always pass through the centre. Okay, so fun fact for you to know. Now, it says find the equation for L. Okay, so it wants the equation of the straight line that passes through the midpoint. Now we know a few things. First of all, we need to know the midpoint. So 2 plus minus 8 is minus 6 divided by 2 minus 3. Minus 2 plus minus 6 is minus 8 divided by 2 minus 4. So we've got the midpoint here. We also know that to find the gradient, we need to find the gradient of the line PQ. And then we know the gradient of the line PQ, when we flip it and multiply it by minus 1, is going to give us the gradient of the line that M and C are on. Okay, so essentially the gradient of the line PQ and the gradient of the line MC, when multiplied together, are going to give us minus 1. So using PQ to find the gradient, we're going to have minus 6 minus minus 2 over 2 minus minus 8, which is minus 4 over 10, which equals minus 2 over 5. So this is the gradient of the line PQ. That means the gradient of the line MC is, we're going to flip it and multiply it by minus 1, which is 5 over 2. We now have the gradient, we now have the midpoint, and we know the equation of a straight line is equal to y equals mx plus 2. So I'm going to substitute these in. So minus 4 equals 5 over 2 lots of minus 3 plus c. So then I'm going to have minus 4 equals minus 15 over 2 plus c. 4 is negative 8 over 2. Negative 8 over 2 plus 15 over 2. c is 7 over 2. Positive 7 over 2. So then that means the equation is y equals 5 over 2x plus 7 over 2. Okay, so I tend to leave it like that. It hasn't told us to leave it any other way. Part B says, given the y-coordinate of C is 9, so it's told us that the y-coordinate of C is 9, find the x-coordinate. So we know then that if the coordinates of C lie on this purple line, we've just figured out the equation. So I can substitute in y equals minus 9 into 5 over 2x plus 7 over 2. I'm going to multiply everything by 2. So minus 18 equals 5x plus 7. Take away 7 from both sides. Minus 25 equals 5x, and divide by 5. X equals negative 5. Okay, therefore we know minus 5 minus 9 is the centre. It then says find the equation of the circle. So what we now have to do is find the radius. Now, how are we going to do that? Now, what do we know? We need to find the length. We know we've got a point on the circle, and now we've got the centre. So we know that C to Q would give us the radius, or C to P would give us the radius. So if I just do C to Q, C and Q, we know Q is 2 minus 6. We know C is minus 5 minus 9. And we're going to go back to our trusty good friend Pythagoras, because we can draw a triangle, a right angled triangle, and find the length. So between minus 5 and 2 is 7. And between minus 9 and minus 6 is 3. So therefore we know that 3 squared plus 7 squared equals the radius squared. Okay, 9 plus 49 is 58. So 58 equals the radius squared. Now, we can, if we want, write that root 58 equals the radius, but ultimately we know the equation of A is x squared plus y squared equals r squared. So we know it's r squared at the end. Now, obviously, this is if the centre is the origin. Ours is not. So ours is going to be x plus 5 squared plus y plus 9 squared equals 58. So nice and simple. You would have got the exact same answer if you'd have chosen CP, okay? Okay, here we have a test your understanding. Take a quick screenshot and then we'll go to the breakout rooms. Okay, so the answer for number 1 was 3x plus 4y minus 54 equals 0. And then for number 2, we have x plus 1 squared plus y minus 7 squared equals 50. Okay, so let's just quickly go through this. A circle has a centre, 3, 5, and goes through the point P, 6, 9. Find the equation of the tangent to the circle at the point P, giving your equation in the form ax plus by plus c equals 0, where a, b, and c are integers. Okay, so to find, I always have to draw circles, I don't know why. I really can't visualise this in my head. So we know the centre's 3, 5. And we know there's a 0.69p, okay? It says find the equation of the tangent. So it wants this equation here, okay? So I know I've got 2 points and I can find the gradient of the radius. The gradient of the radius multiplied by the gradient of the tangent equals -1 because we know a radius meets a tangent at 90 degrees, okay? So what I'm going to do is I'm going to find the gradient of the radius. So 9 minus 5 over 6 minus 3 equals 4 over 3. So this is the gradient of the radius. So that means MR equals the gradient of the tangent is negative 4 over 3. I've now got my point 69. So back to pure 1. Here we go. Y equals mx plus c. So I'm going to get 9 equals minus 4 over 3, lots of 6, plus c. So I'm going to get 9 equals minus 8 plus c. I don't know why I've put a 6 there. So 17 equals c. Sounds about right. Okay, then we're going to have y equals minus 4 over 3x plus 17. It clearly says it wants it as 1. So I'm going to multiply everything by 3. 3y equals minus 4x, 17, 34, 51. Is that right? Oh, absolutely. This should be minus 3 over 4. What a wonderful mistake. I'm so glad you've all spotted it. Okay, make sure that you spot these mistakes early. So let's just cancel all this out. So minus 3 over 4. So we can get 9 equals minus 18 over 4, which is minus 9 over 2 plus c. 18 over 2, I get 27 over 2 equals c. So now I'm going to have y equals mx plus c. Y equals minus 3 over 4x plus 27 over 2. Now to get rid of the fractions, I'm going to multiply by the largest denominator, which is 4. So I'm going to have 4y equals minus 3x plus 54. Rearrange. 3x plus 4y minus 54 equals 0. And that's exactly the answer we've got up here. For part 2, a circle passes through the points A, 0, 0 and B, 4, 2. The centre of the circle has x value of -1. Determine the equation of the circle. So again, let's draw this picture out. So I'm going to have my circle. We know that A is 0, 0, B is 4, 2. Okay, let's just put that here. 0, 0, 4, 2. And the centre is -1 something. -1 y. Determine the equation of the circle. So what do we know about this? We know we've got a chord. So we know the perpendicular bisector of the chord is going to pass through the centre. So I need to find the gradient of the chord. So the gradient of the chord is 2 minus 0 over 4 minus 0, which equals 1/2. That means the gradient of the perpendicular bisector, okay, which is going to be the gradient of the radius essentially. The gradient of the radius or the diameter line is -2. I now need to use my midpoint, which is 2, 1. So I'm going to have gradient is 2, 2, 1. So I'm going to have 1 equals 2 lots of 2 plus c. c equals -3. So it should be -4, so this should be 5. So y equals -2x plus 5. Now when we substitute in -1, we're going to get y equals 7. And that does make sense, that y equals 7. Well, it doesn't actually. Y equals 7, so -1, 7, we're saying is lower. So I've drawn my circle completely wrong, but that's okay. Nobody spotted that. Because if this is -1, so my centre is -1 here, and we don't know what y is. And if we think, where is 0, 0? It's got to be up here. Well, we don't know roughly. Okay, let's do 4. I had to say it was here. 0, 0. And where is 4, 2? I have no idea. Okay, let's just forget drawing of the circle. Right then, anyway, carry on. So then what we have is, we have y equals 7, so we know we're going to have x plus 1 squared plus y minus 7 squared equals our radius squared. So to find our radius, we can use our centre point and any point. I'm going to choose -1, 7 and 4, 2. So we're going to have 5 squared plus 5 squared equals 50. So that means our radius squared equals 50. So therefore, the equation of the straight line is x plus 1 squared plus y minus 7 squared equals 50. Okay, now I need to draw the circle. Right, if this is 7, -1, 7. Okay, so our axis is going to be roughly there. Then we're going to have 0, 0. So it's going to touch here, 0, 0. And then 4, 2, which is here. Oh, okay. 0, 0, and then this would be 4, 2. Perfect. So when you are drawing these, I mean, you know, this type of example, it's just abstract to see what's going on and what rules we need to use. But sometimes for some questions, you will have to draw them a bit more exact to know what's going on. Okay? I'll just zoom out a bit. Yeah, so again, to find the radius, I've used Pythagoras' theorem, as long as you use one of the centre points and one of the points on the outside of the circle. Triangles in circles. Say it with me. Triangles in circles. So, the triangle inscribes the circle. Okay? So, it inscribes the other if these, you can see, these vertices of the triangle are on the circle circumference. Okay? So, the triangle inscribes the circle because essentially the triangle fits inside the circle and all of our vertices are on the circumference. The circle circumscribes the triangle, okay? And this is because the circle is also all of the vertices of the triangle are on the circumference. If the circumscribing shape is a circle, it is known as the circumcircle of the triangle. So the centre of the circumcircle is known as the circumcenter. Okay, what do we know about triangles and circles? Well, first of all, we know from GCSE, okay, if this triangle here makes a 90-degree angle, we know that AC must be the diameter, okay? We know that. So AC is the diameter. Okay, and then similarly, if AC is the diameter of a circle, we know that the midpoint of AC, okay, so we know if it's the diameter, the midpoint of AC is, in fact, the centre. Oh, is it ER? Is this American? No, that's American. Here we go. Centre. Right, okay, moving on. So everyone should be comfortable with this notion, okay? So, given 3 points, given 3 points, 1, 2, 3, a triangle, okay? We can find the centre of the circumcircle. Okay, this is a circumcircle Y. We can find the centre of the circle. Now, how we find the centre of the circle is, we need to find, now this isn't very, so here, we have the perpendicular bisector of this line, okay? And then if we have the perpendicular bisector of this line, we found out where they intersect, and this will give us the equation, the coordinates of the centre of the circle. Okay, so we need to find the equations of perpendicular, find the equations of the perpendicular lines of two sides. You only need to do this for two sides. Okay? Where they intersect will be the centre. Okay? Where they intersect, I think my handwriting is getting worse. Where they intersect will be the centre, okay? So, we're going to prove that a bit later on, but this is what we're going to have, okay? Nice and simple. Okay, so here is an example. If you feel confident to do this, go ahead and do this on your own. If you would like to have a look at the two different methods, then please follow my lead. So the points A, B and C lie on a circle. Show that AB is the diameter of the circle. Now there's two different ways we can do this. If we have to show that AB is the diameter of the circle, we need to prove, okay, now this is where this is going to help us out with proof as well. If this is a diameter of a circle, what do we know? We know if this is the diameter, this angle must be a right angle from our circle theorems, okay? If we have a right angled triangle, how can we prove a triangle is right angled? He's one of our favourite mathematicians. It is Pythagoras. To prove, we know that a squared plus b squared should equal c squared. In this case, our a could either be our CA or CB. I mean AC or BC, yeah? So it doesn't matter which one our A and B is. What does matter is that our C has to be our AB, okay? So we need to write this down. Remember, we're showing that this is the diameter. This is where our proof from chapter 1 is applied throughout pure 2. So we need to prove that AC squared plus BC squared, now remember mathematicians do like things in alphabetical order, so please try and do that, equals AB squared. Okay, perfect. Right. How do I find AC? How am I going to find AC? What do I actually have to do again? I have to do Pythagoras to find the length of AC, but that's okay. Nobody panic. So here we go. So I know that AC from -4 to -8, I know this is 4. From 9 to 1 is 8. So AC is in fact, AC is in fact 8 squared plus 4 squared, square rooted. So AC is in fact root 80. Everyone happy that I did that? Or just went for that? Does anyone want me to break that down? Okay. Now the next one I need to do. So this is my AC squared plus my BC squared. Now my BC. Let's do this. Here's my BC. Okay. -4 to 4 is in fact 8. 9 to 5 is in fact 4. Yeah. So 8 squared plus 4 squared is 80. So BC is root 80. Perfect. Okay, now this equals our AB squared. Now lucky for us, and this is very lucky indeed. This is a straight line, isn't it? Okay? But you can see it's still wonky. So we still have to work it out. Okay? So, from 4 to -8 we have 12. 1 to 5, 4. 12 squared, 144. 4 squared, 16. 144 plus 16, 160? So this is the square root of 160. Okay. So, we know anything squared, square rooted, because the square root is actually power of a half, isn't it? So we know x to the power of a half squared is in fact x to the power of 1, because you multiply the powers, don't you? Okay? So this means that 80 plus 80, oh, I forgot a 0 there, equals 160. Is that true? Yes. Therefore, AB is the diameter. Okay. Right, next way we can prove this. Tell me. Okay, this isn't in the textbook apparently, but come on, we're all amazing mathematicians here. We know right angle triangles, Pythagoras. Great. What else do we know? If this has to be right angle, there has to be 90 degrees here. How else could we prove this? Okay, so we know that lines are perpendicular if they meet at 90 degrees. So essentially, the gradient of AB multiplied by the gradient of BC should equal -1. Why? Because the gradients, if two gradients meet at a right angle, perpendicular, the gradients multiplied by each other will give me -1. So what is the gradient of, sorry, not AB, AC. What is the gradient of AC? So we're going to do y2, where are we? 9 minus 1 over -4 minus -8 equals 8 over 4, which equals 2. Okay? The gradient of BC equals, so 9 minus 5 is 4. Oh, wait there, I didn't write it down. 9 minus 5 over -4 minus 4 equals, what is 9 minus 5? It is in fact 4. -4 minus 4 is -8, which equals -1/2. Okay? So therefore, 2 multiplied by -1/2 equals -1. Therefore, AC is perpendicular to BC. Therefore, AB is the diameter. Perfect. Okay, so that's 2 different methods. Again, there is no right answer here. Both of them will score marks. Part B, hence find the equation of the circle. Well, if we know that AB is the diameter, the midpoint is going to be our centre. What is in the middle of -8 and 4? -2. And what is in the middle of 1 and 5? 3. So here are our coordinates. So I know it's going to be x plus 2 squared plus, not x, y minus 3 squared. And this is going to equal my radius squared. Now, a little bit of a trick. We already worked out the length of AB. We know it's root 160. So, root 160 divided by 2 is in fact root 40. So in your calculators, if you did root 160, divide that by 2 root 10 or root 40, okay? Now we know the circle is radius squared, root 40 squared is 40. Or you would have got in your calculator 2 root 10. If you squared 2 root 10, of course you're going to get 40. So here's our answer, nice and simple. Okay? If you didn't prove it this way, okay, you're not going to have the length, but you will have the midpoint, which you know is -2, 3, and then from there you could do Pythagoras. So between -8 and -2 is 6 squared. Between 1 and 3 is 2, so that's 2 squared, so you're going to have this equals 40. Okay, you can work that out anyway, so don't panic, and as you can see, it literally took a second. Okay, so here is another example, give it a go. So the points 0, 2, 2, 0 and 8, 18 lie on the circumference of a circle. Determine the equation of the circle. Now just a few hints from this one. If you're trying to determine the equation of the circle, you need to, anything you assume, you have to prove. Okay? So, if you wanted to, you could try and prove that CB is a diameter, but you have no guarantee that it is. So you could do all of this work, and it turns out it's not a diameter, and then you have to go to the other method. So I would always suggest, if it doesn't say that, show that it's a diameter or links to anything about diameter, okay, or that the angle BAC could be 90 degrees, which would then ensure that this is the diameter, then you have to use the perpendicular bisector. Find the perpendicular bisector of AC, the perpendicular bisector of AB. Wherever they intersect will be the centre of the circle. So, if we have a look at the perpendicular bisector of the line AB. So AB, step 1, find the gradient of the line AB. So, I'm just going to find the perpendicular bisector of the line AB. So the gradient of the line AB equals 2 minus 0 over 0 minus 2 is going to give me -1. Okay, so if this is the line AB, the perpendicular is going to be +1. So that's what we want. So the gradient equals 1. Okay. Now, what else do we know? So we have a point. We have the midpoint, which we know is, We have the gradient as 1, and the midpoint is also 1, 1. So if we were to do y equals mx plus c, I'm going to get 1 equals 1 plus c, c equals 0. So therefore, the perpendicular bisector, so this line here, is in fact the line y equals x. Okay? Because our plus c is 0. Perfect. Right, now I'm going to find the perpendicular bisector, so the line that crosses through A and C. Step 1. Okay, so AC. What am I going to do? I'm going to find the gradient first of AC. So I'm going to get 18 minus 2 over 8 minus 0 equals 16 over 8, which equals 2. So that then means the gradient of the perpendicular line is going to be equals -1/2. We now need to find the midpoint. Between 8 and 0 is 4. Between 2 and 18 is 10. So we have 4, 10 as our point, and we have the gradient is -1/2. So we're going to have y 10 equals m minus 1/2 x 4 plus c. So I'm going to get 12 equals c. -1/2 times 4 is 2. It's -2, isn't it? So c equals 12. So therefore, the equation of this line is y equals -1/2 x plus 12. So this line is, in fact, this line here. Now we are going to, when 2 points intersect, we can either use substitution or we can make the equations equal to each other. In this case, I'm going to do x equals -1/2 x plus 12. That means 3 over 2x equals 12. That means x equals 8. Okay? X equals 8. Now, I'm going to substitute that back in to y equals x to find our y coordinate. Y equals 8. So that means our centre is, in fact, 8, 8. So 8, 8 is the centre of the circle right here. We've just figured that out, which is fantastic. We then, as we know, we've got x minus 8 squared plus y minus 8 squared equals our radius squared. So we've got to find our radius. Well, we can use any of the midpoints that we've found to help us find our radius. If I choose this midpoint here, which we know is 1, 1, this is 8, 8. We know 8 to 1 is 7.
It's just better to use point C. It's just 10 apart.
Oh yeah, but that should work still, shouldn't it? Oh no, that's never going to work using the midpoint. Why? Because it's not on the circle. Yeah, I've got to use a point. Sorry, I can't use a midpoint. How silly of me. Right, here we go. Let's use C, and we're going to find straight away that our length, because this is 8, 8 as well, we're going to have 0 squared plus 10 squared, which is 10. So our radius is 10, our radius squared is 100. So I'm going to get x minus 8 squared plus y minus 8 squared equals 100. Nice and easy.